So since we have to plug in another point on the parabola, you look at your table of values and it is a real life situation, so you have to ask yourself, what point do I use on my parabola? So it's not like a regular parabola that is an exact parabola. As you can see, if this is the vertex right here, 5, 3, on both sides of the vertex it should be perfectly symmetrical. And of course, one to the left and one to the right is perfectly symmetrical, 2.9 and 2.9. But as you can see, 2 points to the left, it's 2.6, but 2 points to the right, it's 2.5. Now those are very close numbers, 2.5 and 2.6, but those are not exactly symmetrical. And again, 3 points to the left is 2.1, 3 points to the right is 1.9. Again, those numbers are very close in value as well. However, they're not exactly symmetrical. So the most proper point that you should pick in order to come up with the best case scenario of this parabola, the best formula for the parabola, is a point that is perfectly symmetrical. So you can pick either the 4 2.9 or 6 2.9, it won't matter. So I will actually pick the 4 2.9. So I know that when x, my point xy, when x is 4, y is 2.9. And I'm going to plug in x is 2.4, sorry, x is 4 and y is 2.9 into this formula here so that I can figure out what my a value is. So I'll start off by writing y equals a. I have x minus 5 all squared plus 3. So if I plug in y is 2.9, this will be 2.9 equals my a value, which I don't know. X is 4 minus 5 all squared plus 3. So continuing this, I'll have 2.9 equals a 4 minus 5 is negative 1 squared plus 3. Continuing this, this is 2.9 equals negative 1 squared is 1 times a is a, and then I'll have plus 3. Bringing the 3 to the other side, I'm going to get a is equal to 2.9 minus 3. So a is in fact negative 0.1, which makes sense because this is a parabola that opens down if you plotted these points. So I would actually like you to plot these points on here so you can kind of see what the parabola looks like. So my a value is negative 0.1. So now I can write my final answer as y equals negative 0.1 x minus 5 all squared plus 3. And in fact, I should probably write it in the scenario here because we are talking about height as a function of distance. So height is your y value, distance is your x value. So I'll write it as height as a function of distance is equal to negative 0.1, and then I have d minus 5 all squared plus 3. And this is the real life scenario formula for this case. And that's not exact, as you can see. We know that these points are not exact, but this is the best case scenario for this, or the parabola of best fit for this real life scenario. So if you did plug in distance of 0, would you get 0.5? Well, maybe, but not necessarily, because again, this is the parabola of best fit. So can you use the parabola of best fit to indicate what the height would be when the distance is 9 meters? Of course you could. You can come up with an approximate answer, but this is not exact. This is an approximation to this real life problem. It doesn't follow an exact parabola, so obviously this is the best case scenario for the parabola of best fit of this scenario here.